Okay. Right, dear students, in this video we are going to observe mechanism of elimination reaction, which is E1 mechanism in this reaction. When we call it as E1 or when you call it as E2, the E1, E2, these are stands for elimination reactions. We know that elimination is nothing but removal of hydrogen halide from the reaction by taking alkyl halides along with the alcoholic potassium hydroxide. The special condition in that reaction is nothing but the hydrogen is going to be removed from beta hydrogen, is beta hydrogen removal. That's why sometimes we will call they are beta elimination reactions also. Here alcoholic potassium hydroxide, whatever we are going to mention in those reactions, that alcoholic potassium hydroxide is said to be working like a very good dehydrohalogenating agent. So in these reactions, when you are talking about E1 mechanism is nothing but elimination reaction, non-stereospecific mechanism which follows first order chemical kinetics with which is actually undergoing in the presence of polar solvents, polar protic solvents. Let us take an example of E1 mechanism to understand this mechanism of elimination reaction point. I am going to take tertiary butyl bromide along with the dehydrohalogenating agent alcoholic potassium hydroxide. So here I am taking tertiary butyl bromide. I am taking. This is called tertiary butyl bromide. This I am treating with alcoholic KOH. Usually what happens means beta hydrogen will be removed. So this carbon or this carbon, any one of this carbon attached hydrogen is called as beta hydrogen. That hydrogen, if it is removed along with this bromine, that we will call it as dehydrohalogenation reaction. So in this reaction we are going to remove hydrogen from beta carbon and bromine from another adjacent carbon. So then we will be getting a product with an establishment of a double bond between the carbons. Let us see, the product is CH3, here also CH3, and here I am just going to write a double bond here. So the compound what we obtained is an alkene 2-methyl propene. It is 2-methyl propene. The compound what we have taken in the elimination reaction, in this elimination reaction, is a tertiary butyl bromide. This is tertiary butyl bromide. The reagent we have taken is alcoholic potassium hydroxide. This alcoholic potassium hydroxide is a very important reagent for doing this dehydrohalogenation reactions. So anybody asks any question which is the best dehydrohalogenating reagent, means answer is alcoholic potassium hydroxide. Let us see its mechanism step by step. Step 1. When you are writing step 1, need to understand one thing, that you have to separate a bond between carbon and halogen. Carbon halogen bond in alkyl halide must be separated out to prepare a carbocation. So preparation of a carbocation is the most important point under discussion here. So that is going to happen here in this one. So we will take tertiary butyl bromide, and that tertiary butyl bromide is subjected to cleavage between carbon and bromine, producing a carbocation that must be stable carbocation. If it is stable only, the product also we will get A stable product means this is a tertiary carbocation obtained along with bromide. This is Br minus leaving group. This is the step 1. I am going to observe the step 2. I am going to show you step 2. Already we have a carbocation formation happened in this one. This carbocation is going to take place along with the nucleophile, that is OH minus. So this OH minus from the alcoholic potash is reacted with this carbocation, whereas the beta hydrogen will be specially shown. Removal of water takes place, you all know, and this hydrogen and this nucleophile both will form water. So we will remove H2O, okay, and this bond will be shifted here to get the product. The product is nothing but an alkene, that is CH3 double bond CH2, that is 2-methyl propane with the removal of water happened. The two steps we observed here. That means in the first step what we obtained is a carbocation. This is a carbocation, tertiary carbocation. Suppose in any type of reactions tertiary carbocation not obtained, you have to rearrange that compound to get the stable carbocation. Until getting the stable carbocation, you cannot say the final product is major product in the reaction. As per the chemical reaction, the first step is said to be the reaction kinetics. First step is said to be the slow step, which is also called as the rate determining step, whereas the second step is the fast step to get the product. That's why as per the chemical kinetics, the rate of reaction is said to be directly proportional to the concentration, first concentration of the alkyl bromide. So that is nothing but alkyl bromide, that is tertiary alkyl bromide concentration power 1, but nucleophile concentration is not there in the rate constant expression. That's why the order of this reaction is first order reaction, and entirely the rate of reaction as per this reaction kinetics, chemical kinetics, is said to be depending only on the concentration of tertiary butyl bromide, not on the base. Base is nothing but potassium hydroxide. Hence it is a unimolecular reaction. It's a unimolecular reaction. Therefore it is a unimolecular reaction. That's it. That is E1 mechanism we have observed. Once again, just go through what is E1 mechanism, how we have mentioned it. Okay. Thank you. We will see E2 in the next video. Thank you.